I'll try the computer out again. Okay. Mute Okay, presumably you can all hear me, and I can't see any of you, which leads me to believe that I probably started the meeting without video. So bear with me for 1 second while I go back and try to check that. Oh, did I see somebody else with video? If you can put yourself on video. Nope, doesn't appear so. Hold on. Okay, if you can put yourself on, yeah, it appears you can put yourself on video. I see Ben. Just so I can see whether you're all sleeping or not. Okay, that's that. People are coming on video. Okay. There are 25 people on at the moment. I'll wait just a couple of more minutes, see if we get joined by a couple of more. Okay, I guess we're good. If you joined us in the last couple of seconds and you can unmute your video, that would be good, just so I could see you and know who's speaking. If you're speaking, I am giving you the ability to unmute your own video, your own audio. So if you want to say something or ask a question, just unmute the audio and feel free to chime in. And let me just make sure I can hear you if you chime in. Okay, I think I can hear you. All right. What I want to do today is talk about some solutions for your next lab. The next lab is very similar to the previous lab that you did, and except for a couple of things. One, it's going to be written in C, and I think that's probably visible on the screen. And here, if you push one button, it's going to count up each time. Notice it's counting in decimal and not in hex. It's a lot easier to make this count in decimal as opposed to hex. If you push the other button, it's going to count down. And if you push, let's just count all the way down. 6, 5, 4, 3, 2, 1, 0. And if I press the button after 0, it counts backwards to all 9s, and so on. Are you guys seeing this correctly, or is it mirrored? So if it's correctly, if it's mirrored, do a thumbs down. Okay, so all right, so it's just me I'm seeing it mirrored. That's just me. All right, so I can count down. The middle button, if you push it, will reset the counter to 0. All right, that is your next lab. I don't think I put the write-up up on the M drive yet, but I will. But that is basically the same as the previous lab, except it's going to be written in C. And instead of counting in hex, you're going to be counting in decimal, counting up or down in decimal. All right, so now I have, I've got the whole program loaded on this. I'm going to get rid of a few lines here. And we're going to write certain pieces of it. So I'm going to get rid of all of this. Okay, I'm going to share my screen, hopefully. Screen one. Share. Now, can you see a Atmel Studio window, a thumbs up, thumbs down, people? Okay, thank you. That's good. All right, so what I've got here is just a few lines of code. Again, on the slides that I showed you last time that are, I guess, on YouTube as well and on the M drive, I showed you how to create a C program in Atmel Studio. I've got a few lines here. Actually, that's not true. That was actually written today. Just I stole that from. Okay. I've got the include AVR IO.h, which is like the standard IO. And I've got, since I'm going to be using interrupts, I have a include file specifically designed to do interrupts. I then have an 8-bit integer array, unsigned 8-bit integer, and _T is for type, as we talked about last time. And I have each of the patterns for a 7-segment display. And if I throw a comment up here, 3F is a pattern for 0. That's the pattern for 1. All right, why do I put patterns for A through F? My thought is if I, for some reason, output a value between 10 and 15, it would at least show it on the display, and I might get a little bit of debugging information. Value, the 16-bit value here is going to be whatever value I'm displaying. With 16 bits, I can display up to, I guess, 65,000 if I'm not doing negative numbers. I'm only going to display up to 99999, 4 nines. So I need a value greater than 8 bits because that limits me to 256, and 16 bits is the next size up. I have something called strobe reg, which is just which digit I'm going to be strobing. All of these are outside of any function. I kind of glossed over this in ECE 160, but these are global variables, which means they are available to all functions. All right, so for my main program, things I'm going to be concerned about this morning is I'm going to say DDRB is equal to 0xFF. I'm really only using bits, I guess, 0, 1, 2, and 3 to control which digit I'm doing. I'm just going to make them all output. Same thing on port D. Or output. Port D controls the individual segments, and I'm making those all output. And notice I got a wavy red underline. That's because it's DDRB. And if I spell it correctly, it works much better. Right now, with that in mind, I'm going to end my main program for a minute, and I'm going to write a function, and I'm going to call it display digit. I'm going to have it take two parameters. Oops, let's go back here. uint8 underscore t. Right. This is going to display a digit on the display, on the 7-segment display. Let's put a couple of comments here, up above here. Now, which digit you need to somehow label these? You can make it digit 1, 2, 3, and 4 if you want. You can make it digit 0, 1, 2, and 3. You can make the most significant be digit 0 or the least significant. That's the choice you can make. I'm going to say digit 0 is the rightmost. 3 is the leftmost. Right, and that's just a convention. Now, I said, what is what value to display? 0 through F. My display digit routine is going to be able to display any value 0 through F. If the programmer only wants to use it to display 0 through 9, that's okay. All right, so I can do a couple of things. I'm going to say, first of all, port B is equal to 0. I'm going to shut off all digits. I'm then going to say port D, which is my segments A through F, I'm going to say is equal to segtable sub what? Okay, segtable sub what? So if what is 5, I'm going to set port D to the value 6D, which is the bit pattern, which is a pattern for a 5. If I were to, if what was 0, I would set port D equal to 3F, which is the bit pattern for a 0. Okay, now I need to decide which digit to light up. Now, from your experience, you're hopefully all familiar with if I write a 1 to B0, it lights up either the most significant digit or the least significant digit. Right. Now, to tell you the truth, in the last couple of minutes, I did something and I'm not certain whether 1 is the most significant. If I write a 1 to B0, whether it's the least significant or the most significant. So I'm going to make an assumption right now that 0 is the rightmost digit. And I think that's on B0, but I may have it backwards, I'm not sure. So I'm going to say port B is equal to a 1 shifted left by which? That should light up, I believe, and I wish I had the schematic in front of me right now and I don't, but that should light up the least significant digit if which is a 0. And if I'm wrong, well, we'll fix that in a second. And it should be good. So in my main program, I'm going to come up here and I'm going to simply say display digit. Let's light up digit 0, and let's put a 3 there. Now, then I'm just going to say while 1, and we'll spin. So all this should do once it compiles, and I'm going to just move that while 1 so it takes up less space, and we can see the whole program on the screen. So all this should do is put the value 3 on the least significant digit. All right, and let's see, I can't see myself. So what do I do here? All right, now I can see myself. All right, so this is left over. I'm going to do a, debug. Let's start without debugging. All right, and it tells me I have got some errors because I didn't prototype the function. So let's prototype this. Void display digit. All right, now we've got a prototype. It's not critical in a prototype that you put the actual variable names. If you do put them, they need to match whatever is in your actual function definition. All right. Despite all of that, it actually, I guess those were just warning errors, but it actually did put a 3. The problem is it's on the most significant digit, which means I've got the digits backwards. So let's do a little bit of a fix on that. I'm going to say here 3 minus which, and let's try running this again. Debug, start without debugging. Loading, okay, we got a 3 on the least significant digit. Let's just check this out and make sure that we can do it. Let's do digit, which digit is digit 3? So the most significant digit. And let's put a, oh, I don't know, let's put the value 12 there. Let's put a C on that most significant digit. So I'm going to run it again. Start without debugging. Downloading, and I have a C on the most significant digit. So I have written a function. I've done a little bit of testing before I pronounced it 100% correct. I'd probably do a little more testing. But I believe this function is 100% A-OK. So now, I can use this function, and pretty much it's a case of display digit, which, or I probably should have named that where, and what. All right, so now, I want to write some code that's going to just magically take this val value, the 16-bit value, and display it on a screen. Ideally, my main program is just going to have, for now, a while 1. I obviously need to use interrupts. If you recall, I need to strobe that display or update it once every, at least, I think we decided on 1/24th of a second. So I'm going to go to, and I'm going to have to do some timer stuff. All right, so let me, I guess my thought is I can do all the magic, but I want to sort of link it to the data sheets. All right, so what I'm going to do is I'm going to get rid of this line right here. And I'm going to say, let's use timer 0, CTC mode, and that 1/24th of a second, I'm going to do 4.167, 4.166. That's, I think, 60 Hertz. And so I'm going to use the timer in normal mode, and I'm going to do divide by 1024. All right, let's see. Let's just see. Won't do that yet. So I'm going to use a timer in normal mode. So if I launch this, and I go to ECE263 master. Here's my data sheets. All right, got the data sheet. I'm going to go to the chapter on timer 0. And I'm going to go to register description. Okay, can you all see the register description for time array? Give me a thumbs up if you can. Okay. All right, and again, I know it was more than 2 weeks ago when we were doing this, but bear with me, we'll sort of recreate this. We're not using any special modes, we're just using mode 0, so these special pins are going to be the just 0, 0. For wave generation mode, I'm going to be doing normal. It's down here as a table someplace. There we go. I'm going to be doing normal mode, where I set the negative of the delay that I want. When it rolls over to 0, from FF to 0, it will generate an interrupt at that point if I've set it up correctly. So my wave generation mode bits are going to be all zeros. So if you want to just sort of scratch down on a piece of paper, for register A, timer counter control register A, this field is going to be 0 and 0. That field is going to be 0 and 0. And the wave generation mode bits are going to be 0 and 0. So really, that's going to be all zeros. If we look at register B now, right, this force output compare, they're going to be zeros. We're not using any special features. Wave generation mode, the most significant bit is going to be a 0. For clock scaler, right, I want to have 1/60th of a second or 4.167 milliseconds. Now, can I do, there's some magic way to do whiteboard on this, which I haven't done yet.
I'm sorry, what are the values that we're putting for control register B?
For FOC A and B? Was
Yes.
that, the answer is these are both going to be 0. We're not doing any special, we're not doing output compare at all. So those are just going to be 0. The WGM is going to be 0 because we're in normal mode. The clock scaler bits, we need to think about some. And I am trying to figure out how to do whiteboard. And I don't see how to do whiteboard. I'm going to stop sharing the screen for a minute because I think I go back to a different possibility here. No. Share screen. Ah. Okay, if I click on whiteboard and share. All right. Can you see that I just draw a angle line? Thumbs up if you see a line. Okay, all right. Okay, so we if I do a divide by 1024, anyway, I can do text. Okay. If I do a divide by 1024 and I do a count of -65, if I do 65 times 1024, which is my delay, or not the, what's it called? Divide by. So for every 1024 ticks of the 16 megahertz clock, the timer is going to advance by 1. So if I then take and multiply this by 62.5 nanoseconds, that comes out, let me do my calculator here. I think it's 4.1 milliseconds, but let me make sure of that. Oops. Come on, man, we can do this. 24 times 65 times minus 62.5 minus 9. It's 4.16 milliseconds. And I believe if I take the reciprocal of that, if I take the reciprocal of that, it's 240 hertz, which means I'm refreshing each display, each of the 4 displays at 60 hertz. All right, so, and again, that count of 65 or -65 was arrived at by a little bit more calculation, but that's where that number comes from. So if I now stop sharing this, and I go back to sharing screen 1, okay. If I want to divide by 1024 for clock scalar, I need to go down to the CS table, divide by 1024, I need to put a 5101 in that field. Those are the only 2 things I need to do.
Are we supposed to see something, Professor?
Right now, do you see the data sheet?
No.
You don't see the data sheet. Wait a minute. How about now, do you see the data sheet?
No.
No.
You have to share your screen again, I think.
I thought I just did, but maybe I didn't, okay. How about now, can you see the data sheet?
Yes.
Okay, good. Yep. All right, so now we can go back to here. And so I'm going to set up the timer. I'm going to say TCC R0A is equal to, and again, I could just put a 0 there, but for the sake of documentation down the road when you're looking at old code and trying to adopt it to new code, I'm going to do this. Okay, that's for timer register A. And for register B, I'm just going to do one. All right. Now I'm going to say T count 0 equals minus 65. All right. Now, up to this point, let me go back to the data sheet. I've set it up, and every 4.1 milliseconds or so, it is going to go down to this flag. There's a TMAS register. Okay. It is going to set that bit, that overflow bit, when it goes from FF to 0, it's going to set the overflow bit to a 1. In previous code before vacation, we looked at polling that flag each time. And when it became a 1, then we went and did something. It is also possible to not look at this register at all and come back up to the mask register, which is a couple of screens up there. Okay. And if I write a 1 to this interrupt enable bit, POIE 0, if this is 1 and the global interrupt bit is set in the status register, whenever there's an overflow, it will generate an interrupt. So I'm going to set this TI mask bit. If I go back to my code, that's not my code, that's my code. I'm going to say TI mask 0 is equal to, just go back and make sure I've got the name of the bit right. Okay, TOIE 0. So I'm going to set that particular bit to a 1. I could have just, if I wanted to, written a 1 into there, but this kind of tells me I'm enabling the interrupt overflow bit, or interrupt enable for T overflow. Right. The next piece is I'm going to do an SEI, which is the C call to set the I bit to 1. Now from there on in, it should ideally automatically come along and generate an interrupt every time, and somehow the interrupt service routine has got to take val, which for the moment I'm going to, just for testing purposes, let's change that to 1, 2, 3, 4. It's going to take val, split it up into each individual digit, and display it appropriately, calling the display digit routine. So what does the interrupt service routine look like? Well, we saw what it looked like in assembly in C. It is named, it's called ISR, all in caps, and then the name of the vector you put like that. Where do you get the name of the vector from? Well, you go back to the data sheet, and let's go to the chapter on interrupts. And we look at interrupt vectors, and timer 0, okay, timer 0 overflow is timer 0 underscore OVF. So I think I got to fix that OVF. So that is my overflow. So you take the name and then underscore followed by vec in lowercase. I think that's a stupid convention. I don't know why they didn't match it to assembly, but that's what they did. All right, so now what this overflow routine is going to do each time it's called, each 1/240th of a second, it's going to strobe one digit of the display, then return just to this while loop where for the lab you might actually be checking buttons and stuff like that. And then the next time the interrupt happens, it's going to come here and do the next digit and so on. Right, so the first thing I'm going to do here is I'm going to say T count is equal to -65. I'm going to reset that, I'm sorry, T count 0 is equal to -65. I'm going to reset the counter. Then I'm going to use this strobe reg value, and depending on whether strobe reg is 0, 1, 2, or 3, that's going to determine which digit I am going to strobe. So I'm going to say here switch strobe reg and case 0, and there'll be some code there, and then break case 1, and some code and break, some code and break, and case 3. All right, and the last thing that I'm going to do in this interrupt service routine is I'm going to say strobe reg is equal to strobe reg +1 mod, let's do, not mod, let's do ANDed with 3. So each time I'm going to increment strobe reg by 1, and I could do a mod 4 here, or I could do an AND 3. I think an AND 3 is probably a little bit faster. And it's simply going to keep the 2 least significant bits. So the 2 least significant bits are going to go 0, 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0 again. So each time through, I'm going to do exactly 1 digit. And then go back to doing whatever I was doing. Right now, in the case of 0, I believe, let me make sure, let me look at this display digit routine. It sounds like in the case of digit 0, I'm displaying the thousands digit. Is that people's recollection? No, I'm sorry, no, digit 0 is going to be the least significant digit. If I get this backwards, we'll have to go back and fix it. Digit 0 is the least significant digit, so I'm going to say, let's do a temporary variable here. Let's just call it x, u int 8, X. I'm going to say X is equal to val mod 10. So if X is 1, 2, 3, 4, I'm sorry, if val is 1, 2, 3, 4, val mod 10 is 4, the least significant digit. Okay, I could then say what is equal to X and which is equal to 0. We're going to go back probably and streamline this a little bit. Okay. What and which are not actually, so, okay, what I'm going to do is say display digit, which is digit 0, what is X? Okay. And I think that's all we have to do. In the case of 1, I'm going to say X is equal to val divided by 10 mod 10. Now, again, let's say val is 1, 2, 3, 4. Val divided by 10 is 1, 2, 3, integer division. 1, 2, 3 mod 10 is 3. So I've got the next to least most significant digit, and I'm going to say display digit 1 and X. Okay. Here I'm going to say X is equal to val divided by 100 mod 10. Once again, let's say val is 1, 2, 3, 4. 1, 2, 3, 4 divided by 100 is 1, 2. 12 mod 10 is 2. Display digit 2 and X. And the last case here, I'm going to say X is equal to val divided by 1,000. Now, if this could be more than 3 digits, I'd certainly want to do another mod 10. But if I have the most I can have a 4-digit number, then I don't think I need to do much here. And I'm going to say display digit 3 and X. Now, do I want to put a default case in here? Well, maybe. I'm not sure exactly what I want to display if something is wrong. Maybe just for debugging purposes, I can put a default. I'm going to say, I don't know, display digit 0, 15. Let's put an F on the least significant digit. It should never come to that. Strobe red should always be 0, 1, 2, or 3. And I think that's pretty good there. Hopefully you can see we probably can go back and make this a little bit shorter, but for testing purposes, let's see what happens here. All right. I'm going to move this a little bit, say debug. Let's just go for the gold if I hold this up. All right, and I see an error. It says timer overflow vector appears to be a misspelled signal handling. Okay, so let's go back and look at maybe it's timer, oh, maybe it's timer 0. It's probably timer 0 overflow. Let's go back and just make sure of that. This is the data sheet. Yep, okay, timer 0, yeah, timer 0 overflow. Okay, so I got to put a 0 in there. And let's try this now one more time. We'll hold that up. Debug, start without debugging. And it's writing it, and I see 1, 2, 3, 4. Hey, that's a really good sign. Now, let's keep in mind a few things here. If I go back to, oh, okay. By the way, if I hold, can you still see the 1, 2, 3, 4? Thumbs up if you can. Oh, okay, so that's good. Okay. Let's go back to this, and let's look at my main program here. The main program, after it sets stuff up, is just running a while one and nothing else. That's all the main program is doing. The interrupt is firing every 4.1 milliseconds, going into the ISR routine, which is based on strobe reg, setting X to an appropriate value and then calling the display digit routine. And then it goes back to the while loop where it's just spinning. 4 milliseconds is a very long time in terms of 65 times 1024, whatever, about 65,000 clock cycles. It's a long, long time. So most of the time is spent spinning in this loop. Now, if I want to get brave here, let's set value back to 0. And inside of this while loop, inside of the while loop, I'm going to say delay MS 100. And then I'm going to say val plus plus. Okay, and I'm getting that delay because in order to use a delay function, I need to include, I think it's util/delay.h. Okay, yeah. Okay, this is harkens back to 160, but now delay. So I'm going to delay 100 milliseconds, increment value by 1. So that's all my main program does. So I know we're just about out of time here. Go debug. And no, that's okay. Let's just start without debugging. Moving this up. Loading. No. Okay, it gave me an error. I guess you can see it. It gave me a message that says FCPU is not defined. So let's go back to the code here. And before I use delay, I've got to say define F_CPU, and our crystal frequency is 16 megahertz. Let me now, whoops, nope, nope. Debug, start without debugging. All right, and okay. Now that's counting about like a 1/10 of a second stopwatch, I think. And again, let's look at the main program. The main program right here is simply delays by 100 milliseconds, adds 1 to value, and that's all it does. Every 4 milliseconds, this overflow vector fires, overflow interrupt fires. It goes to this ISR routine, this interrupt service routine, resets the count to -65 for 4 milliseconds. Based on strobe reg, which goes 0, 1, 2, 3, 0, 1, 2, 3, it figures out which digit to update, and that's all it does. All right, are there questions? I know somebody, let me stop sharing my screen, and I know there were a couple of comments. Yes, thank you for my background comments. Feel right at home here. Okay, what did shifting port, okay. What did shifting port B 1 Shift left 3 minus which? Okay. Let me share the screen again here. Okay. The question I think is, what did this line right here do? If I put a comment here, if which, or when, oh, let's see. Okay. That is kind of what I want to do.
For the last one, do you mean 3 instead of 0?
I do. Yes, thank you. No, okay, for the last, yes, I do. Yep. Thank you. Okay. If which digit is 0, I want to light up the least significant digit, which is strobed by bit 3 on port B. So I need to make that a 1 and all the other bits 0. Maybe I should put a only here. Okay, if which is 3, then I want to light up the most significant bit, which means bit 0 only should be on of port B. If I simply did a, doing a port B equals 1 shifted by which, is kind of backwards. Now, should I go yell at the hardware designer? Well, that's one option. It would make my code a little bit easier to understand. On the other hand, lots of times hardware people have reasons for doing things in terms of laying out the board, and it's up to the software people to actually make it work. That actually happens a lot more commonly than you might expect. So in order to kind of reverse it, if I take and subtract which from 3 and just shift that, I can make it work correctly so that digit 0 will be the least significant digit. Now the alternative to this one statement is I could do a whole bunch of if-elses. I could do a switch case, but this is just a pretty cute statement that runs pretty fast. So that's why that is the case. Let me look at a couple of other questions I saw. Okay. Oh, it's okay. See, Kevin, I think, was kind of answering that question. Is the code going to be public? Yes, I will drag this onto the M drive right after class. Is the lecture recorded? Yes. Kevin, do you know how to get recorded lectures? I don't actually know how to get recorded lectures. Or does anybody know how to get recorded lectures?
I don't. It might be saved to like some directory, or it might tell you to save it after this.
I think when I started the meeting, it said it was saved in the cloud. It's possible my guess is you can probably click on that meeting ID I sent you and it will say the meeting has ended. Do you want to watch the recording or something like that? But I haven't tried, I don't know. Question about exam 1 grade. That is the unscaled grade. So everybody gets 10 points added to that grade. And again, I wish I had a scanner here. I tried to resurrect my HP all-in-one and it's beyond resurrection, I think. At the worst case, when I can get back into UMass, it's kind of sealed up pretty tight now, but when I can get back into UMass, I will run them through the copy machine and then send them out to you. But that may be the best I can do. I don't know. Okay, somebody says you send us a link afterwards, saved on the host settings. Okay, so I will email out the link. Okay, any other questions? All right. I know a slew of you have sent me emails. I think I've responded to most people. There are probably a couple of people I haven't. I will try to go through that. I have another meeting that starts at 10:30, which I'm going to be busy with, and then I will look and see emails. I will also post the code that we wrote today, and I will post the link to the recording. Any last questions? Okay, folks, again, this is not ideal, but hunker down and we're going to make the best of it. So until Friday, I bid you peace and take care.